my name is Kajetan.
And we would like you to present you this oral presentation and show you how well we are prepared for the upcoming competition. Here's the agenda. First, we will talk about rules and requirements, then project management, design, prototyping, preparation and work division, and at the end, first-time events and risk management.
Here we've got rules and requirements. Well, the goal of this year's competition is to build an RC model, transportation aircraft, which has to have the best possible structural efficiency, and it is required to do a 360-degree circuit over the airfields. It must be 18 kilograms MTOW maximum, but that's the maximum. And here, this year counts the structural efficiency. So it doesn't matter how much do we actually lift. It matters how much do we lift in the ratio of empty mass of the aircraft. There are other requirements here: 2.4 gigahertz radio control system that we have, rectangular bay, and we also comply with this rule. Fixed wing, that's for sure. Electric motor arm plugs, that's normal, and power limiter, which we won't use this year. Here we've got the payload. We created the curve in a way that it is just a bit higher than our actual results from the test flights, so we can reach for the better scoring at the tournament. Here we've got weather analysis graphs. We analyzed weather here in Poland and as well and in Mexico, in Guadalajara. So we compared the density, altitudes, and temperatures, so we could compare the results of our test flights.
Then we have project management. Here you can see our team structure. First, we have faculty advisor, which is Dr. Radosław Górzański. Then we have our team leader, which is Kacper. And then we have the design team, which is Ola and Antoni. Technical report, oral report team, which is us. And then plane construction, which has all experienced team members. And then we assign another team member, for example, unexperienced ones. Here you can see the grant chart, which is the time management of our project. It starts in October when the rules are released, and it ends in March, right in Guadalajara during the competition. Here you have project management. Actually, it's our whiteboard that you can see right there. It's our real-time progress updates. As you can see, we have all checked up because we are ready. The communication, we use Discord for news and all the messages that has to come through our team, and so that we can know whether we have to work or not. Of course, there's always something to do. Here's the design.
So the first prototype that we've created after the design process was made of styrofoam, so it was easier to manufacture, and we could build it really quick. Here we've got a quick video of reverse thrust that we used in the aircraft because there are some bonus points for short landing distance, so we used reverse thrust as innovative feature here. Another innovative feature are the end plates at the empennage of the aircraft, which help to stabilize the construction, since the vertical stabilizer was not enough, as we stated after the test flights. Here you've got prototyping, and here we can see the prototypes. The first one made of styrofoam that actually crashed because of as you can see, because of the styrofoam, its rigidity was not enough for aircraft. When we loaded too much payload, it was overloaded, and it broke during the flight. After the test flights, we stated that we need a bigger fuselage since we could lift more payload that we could actually fit to the prototype one. So here you can see the final result of the construction. Here's something about the empennage. Again, well, the vertical stabilizer now is a bit bigger. We added the end plates as well, and all the decisions were also we made the decisions after the test flights, so we could improve the design. We also at first we used a bigger propeller, which created a lot of thrust, which was too much for our aircraft. It could take off at the distance of just a few meters, and it was too much. So we decided to use a smaller one.
After that, we were pretty much happy with the results. The preparation. We have multiple checklists. For example, here you can see the one before competition, because we use them to know whether we have to take something, bring with us, and we just want to know whether we have everything. Another checklist, it's during the competition. Here you can see the things that we need to take with us, for example, on deck, or we have another checklist for flight, for the team, and for the pilot, because they are pretty much different. And here you can see the pre-flight on-deck checklist, what things we have to do just a moment before flight and after flight as well. Here you can see the checklist for rain or heat in case of bad weather. For example, in case of pretty heavy rain, we have to secure our planes with something, as you can see here. And in case of heat, we will use rescue blankets like this medical foil. Also, we will bring to the competition 4 models, pre-tested with its own electronic system and own engines, and 1 model as spare parts without servos.
And here you can see 2 of them
standing
right behind us. Yeah.
Also, we have safety plugs. Every team member has their own safety plug, because if one gets lost, we can just pass it to them, and it's pretty much easier. Here you can see the payload removal process, the payload bay, the payload box, and how it's connected. Here's a quick video of how they unload it.
Yeah. There's a screw going through the fuselage, which...
Yeah, and then we have work division. We have team captain, which is Kasper, and Mikołaj, who is the pilot, and they're obligated to do pretty much the most important things as the pilot himself, and the team captain that just is responsible for the whole project. Then we have on-deck duo, which are people responsible for the first plane and every other plane that comes to them, which is Julek and Sebastian. Then we have plane 2, which is Ola and Piotrek. They will pass the plane if the first one crashes. Same thing with the plane 3 that me and Ola are responsible for. And spare parts, 4th model, Ola and Antoni are responsible for it. Also, we have the technical inspection team, which is me, Kasper, and Sebastian, that will be going through it during the competition. We have Antoni, who will be responsible for communication, things like monitoring messages and checking results and applications. Then we have first-time events and risk management. We have first-time participants, which is Piotrek and Sebastian. We want to make sure that they feel very good around us and that they will learn. Then we have new roles, because we had a change of leadership and we feel the absence of experienced members.
And here's something about transport and equipment. We are using that kind of boxes, as shown here, to transport the aircraft to Mexico. And we needed to take into consideration some risks. So we thought about weather, payload prediction, and the political situation. As you know, we might have some problems in, well, actually competing. And here you've got a risk matrix. And let's see, we've got the technical ones, the poor rigidity of wings, for example. We replaced the styrofoam wings, which were not enough rigid to stiffen the structure.
That's all. Thank you for your attention.
Thank you very much.
Okay, thank you very much, guys. I have a time of 10 minutes and 5 seconds. I don't know if anyone also take the time just to double check.
Well, we actually took our time too, but I think yours may be better, but we have like equal 10, so.
Okay, yeah, we'll double check with our times that we took. So yeah, so I think Adrian, if you want to start with the questions.
Okay, hello guys.
Hi.
Hi.
First of all, congratulations on the work you have done. And we are truly excited to have you here in Mexico. It means first a lot to us that you chose to compete with us. We sincerely appreciate that trust that you have placed in our event and our organization. I also want to acknowledge and thank you for coming prepared with your flight readiness documentation and procedures. That level of preparation is not something that we consistently see from every team in this competition, and it speaks very highly of you, your standards and commitment to safety. We know that this is more related to the US competition, so we appreciate that information. And also we are looking forward to seeing your aircraft perform and to learn more about the engineering decisions behind it. And with that said, I would like to move on to my questions. I would like to ask the next question. With the high limit rule, how did that geometric constraint influence your configuration selection regarding high wing, biplane, monoplane, box wing? Could you walk us through that design decisions?
Yeah, so it's actually described in the in the report. So there's even a matrix made.
Like a pick chart.
Yeah, a pick chart, exactly. And we chose this configuration since it is pretty easy to build, and since we also participate in other competitions this year, we needed to fit a lot of work in one period of time. So our construction had to be efficient, and since the payload are just
metal
plates, and the payload bay is a rectangular prism, the best way to fit it into the fuselage is just making a fuselage with
payload bay.
Yeah, exactly, and the wings are located at the top of the fuselage because it provides better stability of the aircraft. Well, as you can see, each Antonov aircraft is a high wing configuration, and that means something. That's of course not exactly the reason, but it's a quick comparison. Yeah, an example.
Okay, perfect. Let's go to the risk mitigation. What do you consider is the most critical piece or component in your aircraft? And can you tell us if you have a spare, or what is the plan with that single piece that is more critical?
Okay, so I believe the front landing gear, this part here is well crucial because it can very easily break during tough during hard landings, which, well, occur very often. So we decided to use carbon fiber to strengthen the structure and to make sure it is stiff enough. And we each model has its own front landing gear,
and we have multiple.
Yes, and we have multiple spare ones.
So we can just exchange it in if one breaks.
Yeah, they are made together with the wheels. We made it here, and they are prepared as one package, so we can easily replace it.
Yeah.
Perfect. I have another question. Why the team didn't select a bigger span or a bigger wing surface with these rules?
Well, it's connected with the things we said before. Actually, I believe it's because we have multiple competitions and we had to think about how we will fix all of that things we have to do in, like Kaetan said, one period of time. And when we were satisfied with the results of the prototype, which had the same wingspan, we decided that we don't need to make it bigger because it's okay and it's enough.
And the structural efficiency is crucial here, and not the weight itself. So what we
thought was more important.
Yes. So we can lift almost something around double the empty mass of our aircraft,
or even more. Sometimes depends on the weather.
On the weather, and that satisfies us.
Okay, perfect. Thank you for your answers and for the transparency in your explanations. Congratulations again on the work that you have presented. And we look forward to seeing your aircraft in action. So I will hand it over on the next judge.
Thank you.
Thank you.
Yeah, thank you, Adrian. Let's continue with Francisco.
Hello. In the same manner, congratulations. Being overseas and coming to Mexico, United States, or any other American country, it's really hard work. So congratulations on that. I judged your report on the structural side. So, I wanted to see a little bit more technical stuff, but one thing that really captured my attention is that you say that for low cost, you selected CFRP tubes, right? So carbon fiber reinforced plastics. But for costs, can you explain me a little bit more why are you considering lower cost a really expensive part?
We are thinking here about very light materials. So we could buy cheaper material, aluminium for example, but it still doesn't satisfy our needs for the structural efficiency, especially for the front landing gear, as we said before. And we think that the carbon fiber is the best material in its area structural efficiency.
From
exactly.
The things that we wanted.
Yeah. Okay. I mean, that's good. Remember that as engineers, you are always trying to found or make a substantiation of your answers, right? So every answer is correct, but you have to make your correct assessment. So something that also captured my attention is why did you selected carbon fiber for the landing gear, which its intention is to absorb the impact, right? So carbon fiber is a really rigid material, so it's not good at absorbing high amounts of energy or loads. So probably glass fiber could be better. So what were your decision matrix on that?
Well, here the market is also the thing. Since the carbon fibers are available at the market, and they are in the right geometry, that kind of landing gear can also absorb high forces. And since we buy commercially available landing gears made of carbon, they are available, and they meet our needs for the.
Okay, thank you. So it's a source part, right? So you bought it somewhere, right?
Yeah.
Okay, that's correct. That's what I mean with like substantiate your decisions. So as I said, it would be nice to see more technical stuff both on the report and the presentation. But again, I'm really happy to see Poland again in Mexico. So congratulations on that.
Thank you.
Thank you.
Okay, let's continue with Osiel.
Hi guys, again, congratulations about all the work that you have done. It's like very special. Like you can see from the projects from other people coming from here, from Mexico, that they don't have to overcome that challenge that you have to do, like just bringing the entire parts to Mexico and prepare it in a different language as well. So congratulations from that side. From my side, I evaluated a little bit the side of aerodynamics. As the judges have already mentioned, we would have liked a little bit more of the technical side in both the text, the report, and the presentation itself. However, overall, I think all the judges can realize that you have a really sensible analysis in terms of qualitative data. But my suggestion would be more about moving forward to a more data-driven process. And having said that, we would have expected probably a little bit more of plots and all that type of results, so we can see clearly, like, for example, in all the description that you have done in the report, like about the airfoils and the wing design, you describe pretty much like the characteristics of the airfoils and all that stuff. But that's something that we would like to see probably in a plot, for example. So it's the same like phrase. I don't know if you have it in your own language, like a figure or a plot or a drawing can explain more than a text. So that's something to take into account. From my side, the question would be, like, if you could explain us a little bit more, how did you select your airfoil and how was the wing design process?
All right, so we searched through the literature and internet for heavy lifts and for, well, not heavy lift, high lift airfoils available. We used XFLR5 to calculate them, and here, as stated in the reports, Zelig 1223 was the best possible, since it served enough lift to for our aircraft and for the size we aimed for. The other ones were pretty much well below the level we aimed for, so we decided on Zelig.
Good. And then the surface design, like the entire wingspan and the wing design process, what could you explain me about that?
All right. So here we thought about longer wings because we didn't have time and resources for winglet design. So we decided to make the wings longer, and sorry, I missed the I missed the expression, the ratio of I think you know what I mean. So the tip vortex do not well, the tip to tip vortexes do not influence the lift generated too much.
Okay. Thank you. And last question. I'm not sure. Well, could you explain a little bit what would be what type of issues could you face if you don't consider like the aerodynamic analysis in a fuselage, if you design merely a structural approach? What could you think about it?
I'm sorry. Can you repeat the question? I'm not sure if I understand it well.
Yeah, sorry. So this is mainly because in I think it was not mentioned either in the presentation and the report, but it's mostly about the fuselage. Like if you just could explain a little bit what type of problems could you face in a fuselage design if you don't consider any aerodynamic scenario.
Okay. So the fuselage in case of dynamics. Here the fuselage is in a cross section, in the longitudinal cross section, it is it has a pretty small area. So so the drag generated by it is not does not influence the overall drag generated by the aircraft. And we also shaped the connection between the part with the payload bay. Well, I don't have the fuselage here. I could show it, but we the connection between the fuselage, between the payload bay and the electronic bay is smooth, so we don't have. I would like that to ensure smooth flow over the entire fuselage. So I mean this part here and this part here as well, and sorry. This part here and this part here as well. These compartments are shaped. Well, they are wing shaped. So so part of the fuselage is actually wing shaped. So so that influences the drag generation. It lowers it.
Okay, thanks. Yeah, so as I said, like my advice, like all the things that you have explained, it looks like you have really sensible knowledge and how to take the decisions, how to make the decisions, this type of aeronautical knowledge. Just that probably we would like to see it more in a plot or something that exactly everything that you have described, we can see that in a plot or in a more easier way to show that you have done everything that you are just saying.
Okay, all right.
Okay, I think you know what you mean. Thank you. Thank you.
Yeah, thank you. And well, finally, I will go into the electric project. So yeah, the same. First of all, congratulations. And I know this is a huge effort for you and the university to go and participate in competitions in the US and Mexico and being from Europe and traveling, and I don't know, I know it's a big effort on this, so congratulations. And yeah, basically going on the same line that the previous judges, I would like to advise you that in the next couple of Aerodesign editions in Mexico, for example, you can try to elaborate a little bit more on your methodology to whether you choose any component or any other decision that you make that you have explained here, for example, put it on the report, put it on the presentation, so we can have a a better overview and a better perspective of the work that you have done. Because I'm at the end, we will definitely verify that everything that you have done is working when you have your airplane flying in Mexico. So yeah, just this little advice for you guys. And my question on the electric regard, how would you assess, you were talking about the risk and management and all that stuff, how would you assess the differences on the weather conditions and altitude and this, I don't know, environmental differences between Poland and Mexico, whether if it's in Guadalajara or any other site, even in the US? How do you assess this and how do you prepare for making sure that you are not going above the limits on the 850 watts for this competition?
Well, actually, I think here we have to say that it's mostly from our experience, because we did a few competitions there, and we have to predict whether it will be hotter at the competition where it would take place. For example, here it was like minus 20 Celsius degrees, and it's completely not the weather we will be having during the competition. We know that, but we have to just prepare like we did in a few competitions before. It's mostly from our experience. We have to do a payload prediction, as we did and as we did show you. And we just need to expect something, and then przygotować to pod to. We just have to prepare for that prediction that comes from our calculations mostly, and then we can just do something about pretty bad conditions, for example, like heavy rain or extreme heat. Then we can do that medical foiling or any other foil that will cover our airplanes, and so that won't impact our planes in different way. We just need to estimate and work on our predictions, because there's nothing.
That's all we have.
Yeah, and we can't do much more because we don't know what the weather will be like. Also, we always try to observe the whole weather situation like months before, and just calculate that.
Okay, yeah, thank you for the explanation. And also the other question that I have is, what was your methodology to choose the components on the electric side, like servo motors and the motor, just to be sure that you are going to be in your conditions that you are testing in Poland, that you will be under the limit that we established? Did you make any testing? Any? I don't know if you have multiple options and you ended up choosing anything. Just walk me through this decision.
Well, so we actually have we can call it a risk. So we have one electrical circuit. Well, servos actually are described in the report, and then they are calculated. They generate enough torque to withstand the forces in really severe weather. So they are strong enough. They give even like 2 or 3 times more torque than needed, since we need them to work properly during the competition, and we also reuse them in future models to reduce the costs. And since we are flying with KST servos for a long time, we know that they are very reliable, and and we used them in this model as well. And as for the power and we do the test flights. We did multiple of them, both in like severe conditions in very cold weather, but some test flights were also conducted in hotter days. And in any of these cases, we didn't exceed the
Problems with them.
we didn't exceed the limits. So so we believe we'll be
Fine.
yeah, we'll be fine at the competition.
Okay, yeah, nice. Thank you for responding. And yeah, also congratulations on the reverse thrust. I think that's a very good innovation in order to try to get those bonus points. On my side, that's all of my questions. I don't know if any other of the judges have any more questions, or we are good to go. Okay. So I think that's it.
Sorry, Axel, I had the microphone closed.
Go. We still
just another suggestion, advice, or question as well. During these flights that you have performed already, did you plan to gather any type of data just to some type of correlation with what you have done, or was it in your mind, or did you just decided let's take the plane and see if it flies?
Well, maybe with the first prototype, we did have that thinking, because we want to know if it will fly.
Yeah, and we wanted to do the first test flight before Christmas. So the first prototype was actually really fastly prepared. So at first, yes, but then we there were some conclusions, and we changed things based on what we had there before Christmas. We actually used some cheaper leftover servos, not to use the proper ones in the first prototype.
To see how they will act and.
Yeah, exactly. To just the first idea, and the other the next test flights were better prepared.
Okay, perfect. Yeah, just an advice. Like, it's amazing. Like, not many teams achieved to perform a flight before the competition. So I think from my perspective, it would be very useful that if you're actually going to fly the aircraft and it's already flying, let's gather some data so we can correlate a little bit our results, or be more, like, back up all our decisions that we have made. So that would be my advice. But thank you and congratulations.
Can I have a quick question here? What type of data exactly do you mean?
Any type of data, like it just depends on what you want to evaluate. So, for example, if you are designing the performance of a servo, the speed, exactly, just by the simple fact of ensuring that what's the speed, like the true speed of the aircraft, all those type of things can be useful to back up all your decision making. So it's just depending on what you want to work on it. Like what am I interested in on if I'm going to put my aircraft into the air.
Okay.
All right. Thank you.
Yeah, you can also look for load factors, for example, for the structure design. So you can sense the exact load factors while you're flying, so that overrides any miscalculation, or maybe you perform like a really conservative approach for calculating that, so you have the exact same factor for your flight envelope. So that will be really nice with an accelerometer,
Okay.
Yeah, okay.
From my side, that was everything. Thank you very much.
Okay, so I guess that's all. If anybody has any questions or not, well, we can conclude this session. And again, congratulations, and we hope to see you here in Mexico in nice touch with the mariachi hat in the airplane back there.
Sure.